Hello, welcome to our fourth series of podcasts on marine infrastructure and dive. Um, I happen to be today at the Marine Conference. It's actually, as you can see here, this is the American Society of Civil Engineers, COPRI, and COPRI stands for Coast, Oceans, Ports, and Rivers Institute. So everything that relates to marine infrastructure falls under COPRI. And this is the Louisiana chapter that they're having uh, an annual seminar today. So I've come to this beautiful, the campus of Louisiana State University, gorgeous sunny day, about 65, 70 degrees right now. And the conference is going on. I just stepped out to do this podcast. I'm here and Josh is in
Yeah.
Tucson. Hello, Josh.
Hey, how you guys doing? Welcome back. Yeah, Mo's out in Louisiana. I mean, this conference, we usually go to ports every 3 years, the main ports conference, right? But is this connected
Yeah.
to that?
Yeah, it's basically like, a bunch of these chapters that make up the whole big ports organization. Yeah. Yeah.
Yeah. So some
So
of you listening might, if you ever go to the ports conference, we're there every 3 years. Last year was Hawaii, and I think the Northeast is getting the next one. But this looks like something that has to do with that, which ports is a great place for us because obviously piles, the seawalls, I mean, everything is there. But how's that show going, Mo? I mean, you gave a
yeah, the
talk, correct?
show is, the show is really good. They have, um, I would say maybe around 70, 80 or close to 100 maybe people in attendance here. There's not, we were not sure if there was going to be a big trade show along with this or not. So there's only a couple of us companies that are have given a little table to display some of our products as sponsors of the conference. We had yeah, there's one company actually that uh, they have kind of an interesting product that I have seen at some of these conferences. They for flood protection that they can quickly set up a wall to prevent flooding of areas. So, but
Wow.
there have
Yeah.
been talks about, some people, some speakers this morning were talking about funding opportunities for the ports if they want to renovate or expand their port capacities, how to do it. And right now, actually, and I feel bad that I had to step away because right now there is an ethics talk going on by the former, our friend and former ASCE uh, president, Norma Jean Mattei. She was actually, Josh, you may remember, she was at the ports conference in
Yeah.
Hawaii when she was there. And but she's a professor at the University of Louisiana. So anyway, she's giving a talk on ethics and of interest, a really interesting subject because the topic her discussions are about how does artificial intelligence interact with ethics in engineering. So really, I
That's interesting.
enjoyed the first 40 minutes of a talk, but now, that I had to step out to, run this podcast together.
Yeah, no, interesting. And then you were gone uh last week in Mexico, and you're giving a
Yeah.
speech out there too, right?
Yeah. Last week was really kind of, yeah, that was kind of interesting. We have recently finished a project in Mexico where we repaired about 75, 76 steel piles in Ofos. Inofos is a chemical uh, corporation that they had their own private port that we were repairing those. Some of those steel piles had 100% section loss. So it was really interesting that we used our ShearWrap system on that job. But then as a result of that work, uh, the, an office or an organization within the government of Mexico, which is the Instituto Mexicano de Transportación. So it's basically the uh, Mexican Transportation Institute, which is an arm of their department, their transportation agency in charge of all of the ports and piers. So they became interested in how we were repairing that port and set up this one-day seminar in Queretaro, which is their headquarters of their office last Friday. And that was really interesting too. There were about 7 or 8 speakers. I gave a talk along with other people on their repair systems. So there's a lot of port repair
Yeah.
activities going on all over the world, it seems.
Well, and then you definitely got to sit down with our client out there, which was one of the projects we've been discussing, the shear wraps going onto these steel pipe piles. So you had a chance to sit down with them, and I know you got some footage with those guys that we're going to have connected to this podcast, so people can tune into that. But they go over their project, right? I'm pretty sure they go over some of the items within the project, so maybe some people can hear from a firsthand perspective.
Yeah, that thing is really, on this is, for our engineer friends, they can appreciate what this discussions that I'm going to have about shear wraps. So, if you're repairing a concrete or timber pile, usually the rough surface of that concrete or timber is good enough for transfer of bond between the old pile and the concrete ring that we cast around it. But if the original pile is made out of steel, whether it is circular or H pile, as we cannot assume that there is a good bond transfer of loads between that old steel, which sometimes is even missing or deteriorated severely, and the new body of concrete that we cast around it. So as the engineers are familiar with this, in bridge construction, for example, when we use composite construction, we weld shear studs to the surface of the steel girder to transfer that load. Well, that can be done also in water, except that welding underwater is really difficult and expensive.
Yeah.
And in some cases, they don't even allow welding because as this was the case in one of these jobs that we were doing in Texas, in Houston, a couple of 3-4 years ago, there were a lot of flammable materials on that site, so no welding was allowed, and that forced us to come up with a solution that we call the shear wrap. So the shear wrap basically is if you think of it, it's like a belt.
I do have it right here. Let's see if I can get a good view.
Perfect. Oh, great.
Yeah,
Josh,
no,
perfect. Then you can.
Yeah.
So as Josh is holding this, you can see that this is, typically these belts are like around maybe 3 inches wide and by, like a 1/4 inch or 3/16 of an inch in thickness. And then there are 2 bolts on the 2 ends of it that Josh is, so they come in 2 half circles as Josh is demonstrating to you. So you can put them loosely around the pile at a higher elevation. And then you loosely put the knot in. Now you can slide this up and down along the height of the pile and then when it gets to that, so when it gets to that final location, you torque it to a specific torque that we designed for. And based on that torque, then the loads from that concrete gets transferred, to the pile. Yeah, that's the torque range.
And so basically, that one project out in Texas went from, hey, you can't use hot work, to this is kind of the item that they had, because essentially that's what it was in Texas. They were like, hey, no hot work at this place. We're not going to give you a permit for that. And then you come on with something like this, or even the guys in Mexico had a different type of system they were using. Could you expand a little on that? Because you know a little bit more about, you saw that. I didn't really see it.
Yeah, the folks in Mexico, they used an electrical torque wrench, which is digitally, you can put in the exact torque that you want to apply, and it just applies it, and then it stops at that. So it's really a well calibrated and a nice system that can be used. So that's what they used in the
video. People can see them, right? The video that people see, they see that in there.
Okay. They will be seeing it in the video that we follow this. But Josh, if you want to hold that, because the side of these, you see, they have some wings on the side of it. Yeah.
Oh, okay.
So, you see those wings that you see on the sides? These provide the bearing capacity of the shear wrap. So we can, calculate. We provide the calculations for this. You don't need to worry about that. But let's say, for example, each one of these shear wraps may be good for transferring, say, 40,000 pounds or 50,000 pounds of load. So then if we want to do, say, 200,000 pounds of load transfer, we would use 4 of these or 5 of these, depending on the capacity of each individual shear wrap. And normally, how we use these is, so let's say if you have a pile with a section of it that is totally deteriorated or has a big hole in it that you cannot rely on the strength of the pile.
I'll share my screen if I.
Yeah,
I don't know if there's a way for me to share it, but I have that slider to show. If we could show that slide, if not, we could tag it on at the end. Let's see.
Can we try to show that? See if it works.
Yeah, let me see if I don't know if there's a way for me to be allowed. I don't know if you can enable the host to do it, but I have it here. I just can't share it at the moment.
Okay, maybe maybe later.
Yeah, we could tag it on at the end. People could get a good view of exactly what's happening.
That animation. So basically, imagine that you have at mid height of a pile, you have a deteriorated or missing section of the pile. You put a few of these shear wraps above it and a few of these shear wraps below that, and tighten these to the appropriate torque. Now, as the loads come through that ring of concrete, when they get to that shear wrap, they get out of from the steel. They go into fully to the ring of concrete, and then down past the damaged portion, then below the damaged portion, through those shear wraps below, they get back into the good portion of the steel. So this way, we provide a continuous load path for the loads to go from the top of the pile, at the pier or deck, all the way to the foundation. That's the function of the shear wrap. So shear wrap is used, as the one that Josh shows you. That one is used for cylindrical or pipe piles, basically. And then we have a different version of it. Yeah, and then we have the one that Josh is holding now. It's called the shear clamp, and that one can be attached to the flanges of an H pile. Yeah, exactly, like that. And then again, each one of these may be good for 15,000 or 20,000 pound, whatever capacity, and we can put multiples of these on the flange of an H pile to make sure that we get a proper load transfer. So both of these devices were developed. By the way, we received a patent on these, but both of these were developed to prevent us from having to weld anything on a job site. So that's significant.
I mean, there's a few things that when I remember dealing with the project in New York on these clamps, and I remember when I got the call, it was from the contractor that was not agreeing with the design in place, and the design in place, and this was not even underwater. The design in place at the time was to surface prep the flanges of the H pile near white, and then they were asking them to weld on it. And this was also in the ground, and the contractor was like, I'm not going to do this. It's going to take forever. You guys have a better solution. So we gave them this solution, and I remember that they beat the target date, I would say, by at least a third of the time. They did it in about 2/3 of the original time that had been anticipated. So they not only got away from the welding, but they actually sped that project up so fast that they were done before we knew it. And that was a good example of this product being used out there. They were very happy, and it just shows the capability of us having to get people steered away from welding.
And in fact, that one, Josh, was not even on water. It was on land. It was a Kmart.
It was on land.
Or something.
Yeah. It was underneath
the foundation of a Kmart or some big department store like that.
Big department store, but they were built on some H piles, but it was correct. It was all dry, but the contractor still did not want to. And then you got to also think, if we have a contractor on land that's saying, I don't want to bring these to near white to do the proper welding. Well, what do you think is going to happen in water? And is an engineer really who's specifying welding underwater feel as comfortable knowing that weld is going to be bonded as as well as it should be without maybe proper surface prep. And that's
Yeah,
something I know that contractors have very tough time with on steel is, you know, dealing with the surface prep. That surface prep window you got, right? Even though you
yeah,
surface prep it, you've got a short window. So that that's why I really like to talk to people when they call about this is um yeah, I've definitely dealt with hot work permits in the past. Um, surface prep, big thing in our industry. Near white is, everybody knows who does that. Very difficult to do. Um, so,
yeah. And
and yeah,
Josh, as you say, like even as from an inspection point of view, to make sure that the quality control is done, because with every inch of welding that you're performing down underwater, somebody has to either rely on the good quality that that workman is putting in place, or somebody be able to inspect this, which really adds a lot of challenges. These products that we have developed, they are made obviously in our manufacturing facility, and then all you're really relying on are just with the torque bolt, to make sure that you torque it to the right level, and then you're done. There's nothing else, to worry about. So it makes it easier
and
to install.
I did have a talk yesterday with a large engineering firm that he did tell me on the phone that was why he specified our product was once he found out no welding, it was almost like that sold him right away. So I know we say that, but there's a lot more behind it than just saying no welding, right? Surface prep, inspections, all this
And
stuff.
related to this, we just recently had a call from one of our competitors, which is great. We don't mind working with our competitors, but they had a job that they had a almost, if I'm not mistaken, it was like a 60-inch diameter or 54-inch diameter steel pile that they were repairing. They were not strengthening it. They were only providing some cathodic protection around it, and they were putting like a ring of 3-4 inch thick ring of concrete around that pile. So their main concern was that with this huge mass of concrete going 20, 30 feet tall, that ring of concrete would not stay in place and fall down. So we
Yeah.
made them some very large shear wraps, not so
Yep.
much for transferring big loads, but just enough, tensioning it enough to hold the weight of that concrete.
And,
And those, in fact, for those guys, because the pieces, the diameter was so large, we made the shear wrap in 3 segments, each of them 120
yep.
degrees. That made it a lot easier for shipment, and also,
Hey,
the
anybody out there worrying about the bond or that grout to steel, especially a splash zone repair? I mean, this would ease that, right? I mean, it's going to hold that up there, and um, you know, I could see there being a lot of unease with some steel pipe pile projects and having that grout just sitting up there and that weight. So yeah,
yeah,
that definitely is. Um, one last thing, Mo, that you said earlier, and I don't know if maybe you want to mention that in this podcast, but you mentioned something about funding for these ports, and I know you were dealing with one of our clients recently that you helped
yeah.
connect them with
This is
funding.
yeah.
Maybe
I'm,
can
I'm
you tap on that before we leave today? Because that might be some good information to give to people that we can help them out with.
Yeah, maybe we could actually ask these guys as a guest speaker to come. So as you know, there's a lot of government funding that is becoming more and more available for ports to expand or renovate their facilities. And when I was at that Inland Rivers and Ports Terminal Conference, in Louisville, a couple, last month or so, one of the speakers, there were a couple of people that gave a presentation, and these folks are, uh, they help ports to write grant proposals. That's really their expertise, that they know how to write these grant proposals to improve your chances of getting funding from the government. And so there was a port, one of our clients that has a project in Alaska, and I put him in touch with those folks so that maybe they could help him write for the grant proposal to hopefully get the funding for renovation of the airports. And today, again, at this conference, there's always a lot of talk about, funding becoming available and people, different ports getting funding from the government. So I think that's just something we have to put on our list of maybe one of the topics. Not so much engineering, but but if
Yeah.
you don't have the money to fix
Well, we
it,
can
that's a
help.
facility.
No, but we can help, and I think it's good for us to mention that to everybody out there because not only with the Alaska one did they need to request the funding, but they also need to know how much they might need. And with what we do in the infrastructure, we can help estimate out ROMs for them, some budgetary numbers that might help them give them an idea for what they're requesting. So I know that
Yeah.
they might not think we're not a place to necessarily provide the funding, but we can help assist, get them to the right people. We can help assist with these budgetary numbers to actually get the funding. So I thought it'd be good to mention that to everybody. And yeah, maybe we do have another episode that we can maybe dive into it deeper. But I know we
Sure.
don't.
And talking of episodes, as we get kind of close to the end of this one, so we can run some of that video that we did in Mexico last week, I want to mention that as we do these on the first Thursday, I've been traveling a lot. As you've noticed, I've been. I didn't realize how much I travel until now because of this podcast. I realized that hey, I'm gone a lot. And next month, Josh and I both are going to be coming to you live from Nashville at the Docks Expo. It's going to be, the first Thursday in December will be December 7th. Josh and I will be in Nashville at the Docks Expo. This is really a good show. We've done it a couple of times. And the show will be on Wednesday and Thursday. So Thursday would be the last day of the show, but I'm sure we'll be able to find a few minutes on the floor of the. Maybe we'll go around and talk to some of the vendors on that floor and see, introduce some of the other products you folks.
Our next episode might be a day in the life of dealing with the trade shows and the different things we see, because it's not just everything we deal with. We definitely are sharing space with a lot of different other awesome products that we see, and it's always cool and environment to be in those areas. So yeah, we'll definitely everyone gets that peek and to see, and that'd be really cool. So yeah, I mean,
that's really great. So I think it's almost like time if we have like 10 minutes or something left to show some of those videos that we had from the Mexico trip last week and interviewing with that contractor. And I'm from the campus of Louisiana State University going to sign off, and looking forward to seeing you with Josh next month, coming to you from Nashville. Everyone, you have a great day. Thank you, Josh. Let it go, and then we can, we will clip this.
Professor, how you doing?
Hey. Hello, friends. We are here in the beautiful city of Queretaro in Mexico, where it is what is the name of this Instituto
Mexicano del Transporte.
Yeah, it's like the Mexican government's Department of Division of the Transport
Institute.
Come on, you're the main man. Come on, please join us. We have a surprise guest here. Dr. Trinidad. He's the man who has organized this wonderful conference. One day, it's all about corrosion in marine infrastructure. We've had a lot of good talks and a good lunch, and now this is in the afternoon where the session is going to continue. So thank you so much.
Dr. Trinidad is one of the first, or the main investigators here. He's a scientist, he's a doctor, and he does research here on
corrosion issues.
Corrosion and concrete and all kinds of stuff.
I really appreciate it. It's been great. So what, you guys go ahead and introduce yourself if you'd like to.
Well, my name is Eugenio Martinez, and I work for No Leaks for No Leaks. It's a company based in Coatzacoalcos, Veracruz, and I'm a project manager. And here's Vicente Perez.
Hi.
And
Vicente, I should say, Vicente is a professional diver. He did his training in Santa Barbara, California. Now he lives in Mexico, of course, but he's a real diver.
And he's in charge. He was in charge of the project that we had in Coatzacoalcos. He did all the operations and all the restoration of the piles. We did a total of 76 steel piles in 6 months.
Yeah.
time. So
And they were, what was like the diameter and length of the?
Most of them were 14 inches.
Okay.
Some of them, a few of them, which causes us some trouble, were 16,
16,
and more.
Yeah.
But the vast majority of them were 14 inches in diameter.
And I think
Steel piles.
And I think the problem that Vicente talks about, it was mostly about the size of those shear wraps, because we need to make the shear wraps the right size. So if whether it is 14 or 16 inches, you have to get the right.
Yeah, we had to play with the bolts,
size,
the length of the bolts to make those shear flanges fit.
Yeah.
But we ended up doing a good job. We finished all of them. Some of the piles, well, most of the piles were badly damaged with lots of holes on them.
Yeah.
We file a report for every pile where you could read the total area of pile that was missing.
Oh, I see.
By measuring. We send the divers down with a camera to do a video, and with a measuring tape measure every hole on every pile, so we can calculate the area that the pile was missing.
I see.
And in most cases it was a big area. Some of the piles were even missing. They
So
were
you could run your hands
you
through
can
it.
run your hands through, and there was no pile there. Just a piece sticking from the ceiling, and another piece is sticking from the ground.
Yeah.
So we connected those two pieces with PileMedic as a center, and then we did the complete installation around that and poured the concrete, and they were back to life again.
That's great. Yeah, they made a good video of this, by the way, and we should be able to put that edited video on our YouTube channel pretty soon, so you can see all of the good work that these folks did. That they had a really good, well-organized crew, which is a success to any project. So that was really big. And I think, weren't you saying that at the end that the client was?
Yeah, at the end of the job, the management, the project managers, which were, by the way, were ladies, an engineer and an architect. They came over and came on board, gave us a speech where they said that they were really happy with their work, with our performance, with the speed at which we did these things, with the safety. Safety is a big issue in that plant.
Yeah.
Inofos is very particular about safety and personal equipment, personal protection equipment, PPE, and everything. So we made them very happy. They said they were very happy, and they were expecting us back with more work, more repair work in the future, near future, hopefully.
Yeah. Because on that site, how many total piles on that job?
well, there's around 500 piles that need to be fixed, and we started with at least 76, and the next phase of the job is going to be around 200 to 250 piles. So we're expecting to start that next year and to finish in the next year too. We have a lot of experience, and we have a lot of good operations. We did everything so good that the client is so happy and they want to give us more work.
Oh, wonderful.
And right now we finished the restoration of the piles, but we are having a contract now to identify each of the piles. So in a couple of weeks or maybe a month, we're gonna go back to the job site and we're gonna tie it around them and stainless steel plate.
I see that.
Where we're
Tag
gonna
them, yeah.
tag them. We're gonna tag all of them.
Oh, that's really nice.
Yeah,
that's
a little
a good
side job.
Yeah.
Little side job. And we did encounter a lot of problems while we were applying the PileMedic on every pile, but well, every job has its difficulties, and we overcame them, and everything was perfect. We did a little things that weren't incorporated into the method of applying the PileMedic, and I think it's a good thing because we can extend that to Dr. Mo, and he can implement those things to a new product to develop a better solution.
Yeah, we're always interested in improving the system, and with every job that we do, we learn something good about, the pluses of how the job, what improvements the installing contractors suggest. So that's always a great way to improve the product. Yeah.
Yeah, but everything was fine. We got the piles back to its 100% shape. So
wonderful.
Everyone was so happy about it, and we're expecting us back, as Engineer Vicente told us.
Yeah, no, that's really good. I mean, thank you for you guys doing a great job on.
Thank you for having us here.
And now we all have to go back and listen to the other speakers in the conference. So
Bye-bye.
here is, by the way, look at this. Let's see this little car that was here. Look at this old car that they have in the
Transportation Institute. Take care, everyone.
Bye.